Classwork 3.7 is our last classwork for logarithms. Woo! Right? Woo! And there's not a whole lot more to say. The main issue today is making sure you're clear about the difference of what you can do without a calculator and also how to use your calculator on top of that. So first I have some problems that are solving equations without a calculator. So I expect that you're able to do the following. Let me get my pen going. So with number 1, you guys can all see number 1. That was a delay. Okay. If you have exponential equations and you're trying to solve for that exponent where the variable is, most of the time you're going to need a calculator. It's actually rare that you can get by without a calculator. And the only situation you have is if there's a common base that you can write the numbers as. So 4, everybody, 4 is what in an exponential? 4 is equal to blank to the power of blank. Yes.
I think it's 3 would be
32. For 32, that's actually 2 to the 5th power. Huh? Oh. Wait. No. Yeah, it's not quite a nice integer. But yeah, you're thinking about it, which is that's the way you start down your math road, is just thinking about it and making mistakes. In fact, I think more mistakes happen in math class than any other class. It's almost expected. So then 32 is to the 5th power. Before you move on, though, you use an exponent rule. What do I need to do to the 2 and the x right there with the exponent rule? And I'm looking in chat. Yes, multiply. So that means I have 2 to the 2x is equal to 2 to the 5th. And now you've been told that basically you can just take the exponents and make them equal to each other. Now, if you're happy with that explanation and you don't want to hear what I'm about to say, you can go ahead and plug your ears. I want to point out that what you can do is you can do the inverse to both sides of the equation. And technically that is what is going on. We just kind of went around this. And the inverse operations cancel each other out, and you end up with just the exponent 2x and the exponent 5. You do not at all need to show me this step. I just wanted to point it out to you. Because when we solve our log equations, I'm always bringing in the inverse, so seeing this might help a little bit with that. Might help, might not help. But we end up with 5/2. On number 2, 125 is equal to some nice little number to a certain power. What is that? And then what's the base number?
5 to the 3rd.
Right, you got it. 5 to the 3rd power. And then just to point it out again, we multiply the 3 and the x together right there. And then 625. That is 5 multiplied how many times? I already see. Or, yeah. So you do not need to write the step of taking log base 5 of both sides. You can just go straight to, that means the exponents have to be equal, and you end up getting 4 divided by 3. And you know how logarithms, you have to check for extraneous solutions? You don't have to do that with exponential functions, because if you recall, their domain is everything from negative to positive infinity. But logarithms have that issue. You know what? I'm going to come back to this, and I'm going to move down to numbers 13 and 14, because I want to make sure you're clear about exponential equations. And okay, hold on. Let me get my words together. Fourth period. Okay. So I just showed you how you can solve exponential equations where your variable is in the exponent without a calculator, but it has to be special circumstances. So how can you use your calculator to solve exponentials? What you want to do is, most of your calculators have a log button. Do you have your calculator with you? Does everyone have a calculator? Excellent. You have a button that says LOG on it, just plain LOG. You need to look at a calculator of some type, even if you got to use your phone's calculator, something. Everyone's got a calculator open. What is the understood base of just plain log?
10.
Yes, thank you. Now, what that means is when you see 10 to the power of x, this is going to be nice. If you see any other base, it's not necessarily going to be nice. So what I'm going to do is I'm going to log both sides. And the left side was 10 to the x, the right side was 4.305. Because I understand that this is a base 10 logarithm, the log and the exponential cancel each other out and leave x on its lonesome. Then you can use your calculator to find the log of 4.305. So everyone, get that calculator out. Make sure that you know how to use it. Whoa, whoa, whoa. Is someone on an airplane? Or a train? Lucy, you look like you're on an airplane or a train or a bus or something.
My connection's really bad, so sorry if I disconnect.
I believe you. It is hard to get a good connection if you're moving. Oh, it's okay. I was just surprised when I suddenly realized that somebody was like on a moving vehicle.
Yeah. I'm going up to Ventura, so I'll be on the train for 4 hours.
Yay. Did everyone use their calculator? What number did you get with your calculator? And also, when it says 3 decimal places, have 3 digits after the decimal point. So with checking chat, it looks like we are getting 0.634, and that would be the answer. That is your value of x.
My calculator literally just freezes up whenever I try to.
Are you serious?
jerking.
I know, that's horrible.
I try to type in something and it's just like, nah, I'm gonna die.
Is it a particularly old calculator?
It's one of those ones that you buy at like
Ah,
the plastic thing.
okay. You might actually be better off using like a calculator on a phone. And hey, since I really can't stop you from using a phone, and I'm not even going to try during a test because I can't tell whether you have a phone next to you or not. And some of you are actually using your phones. But anyway, you've got to find somehow a way to use a calculator for when you take this test. Okay. Putting it in rice? Okay. Now, we need to talk about number 14. Number 14 is not a base 10 exponential. So listen very, very, very carefully. There are very few calculators that will allow you to put a base in for a logarithm. Most of them are just automatically, they have a log button and it's a base 10 logarithm. You don't want any extra formulas. So I'm going to show you how to get around having to memorize a, quote, change of base formula. You don't need it. You can go around it. Here we go. Just like with number 13, you're going to log both sides, but know that you are logging with base 10. You're not logging like cutting a tree down. Ha, 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 ha. What if your if your calculator lets you put bases in, you can feel free. And I'll talk about that in a moment. I want to first talk about this issue because I think for some reason most calculators still don't have that ability.
Yeah, mine is just
Yeah. Now, we have a rule that you already have to know, that you already have to use, where you take the exponent inside a logarithm, and where does it go? One of our new log rules. Where can I put that? And what is the operation that the exponent has with the logarithm? Yep, you got it, multiplication. So I don't have to write a multiplication sign, but that particular rule is what's going to get you around having to deal with some change of base formula. So I want to just kind of overemphasize the bringing to the front that x. Now you have two base 10 logarithms. And when you isolate x, since it's just multiplying by some number that happens to be log 5, you can just divide by it. So with your calculator, you're going to find the log of 0.316, and you are going to divide that by the log of 5. And what do you end up getting? Oh, yeah, I'm actually surprised she's able to get into the classroom with traveling. So calculators, does anyone have their calculator answer yet? And I can show you what number you should be getting. Okay, so basically you might need to first find the value of log of 0.316, then find log of 5, and then divide the two. You might have to do that. Let me open up my answers. So you mean you put the number in and then you push the log button and it gives you an answer?
Yes.
Okay. Yeah, so what you're going to do is you're going to put 0.316, push the log button, write down that number. Then 5, push the log button, write that number down, and then divide the 2. And log, what?
Are you sure you want me to write down the number for 136? It's pretty frequent.
Just write a few digits down the line. Because I know that there are a variety of issues with the calculators, and I don't have the ability to come around and actually physically see what calculator you're using, so I can help you with it. And I also don't have a class set of calculators to give out to you. So log 5, hold on.
The first two numbers of log 5.
Ha 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 ha. So log 5 is 0.69897, and that's more than enough. So eventually you should be able to get negative 0.716, but everyone's calculator is a little bit different. If you have the ability to use parentheses, then you can just like start a parentheses and then do the log of 0.316 in parentheses, division sign, and then parentheses log 5. Although you probably don't need the parentheses, but what you need to do is use the calculator you're going to use when you take the test. Okay. And make sure that you know how to use whatever calculator you have. Now, if you're lucky enough to have a calculator that will allow you to put the base of the logarithm in, do you know how quick this is? You can basically just, let me get my pen ready. If your calculator allows you to put the base number of the log in, you can take this equation and instead of log base 10ing both sides, you can log with the base that it has for the exponential. So if I log base 5 both sides, that means that these two completely cancel each other out. The left side of the equation is x. And all you have to do is ask it to find the log base 5 of 0.316. And as long as you are getting the same number, you are good to go. My guess is when you guys are parents of high school kids, all the calculators will probably be able to put bases in for the logarithms. Frankly, I'm surprised that they don't at this point. Because if you can put any base you want in, we don't need to go through this much discussion about how to solve the equations. Okay, any questions on using the calculator? Because this is probably the most important thing of today, is that you figure out how to use your calculators for problems 10 and 11. Okay, so I am going to go back to all the problems. But right now what I'm going to do is move over to 15 and 16. These are problems where you definitely want a calculator, but this is going to be faster. Whatever the base is of that logarithm, use an exponential where, so this is base 5, you're going to 5 to the power both sides. When you 5 to the power both sides, the 5 and the log base 5 cancel each other, and you just need to use your calculator to find 5 to the power of 1.253. On 16, because it's an understood base 10, you can quickly just go, hey, 10 to the power of both sides, and then go, oh, hey, what's 10 to the power of 1/2? And let your calculator find those numbers. And let me display the answers to those just to make sure that you are using your calculator well. And please let me know if you're having any troubles using your calculator that you happen to have. Or if you need me to help you figure out how to get to a calculator. Okay, then I'm gonna, how do you find 15? Oh, number 15. So your calculator has either a button that says X to the Y, or it has a button that has this symbol on it. For most calculators, you're going to first put the base number and then push that particular button and then put the exponent number. Other calculators, you actually have to put the exponent in first, then push a button, and then put the base. So you've got to know your calculator and how it in particular works. And then with 10 to the 1/2 power, you can just do square root of 10, but know that you can also use this technique that I'm showing you here and do it with a 1/2. So does everyone know how to do the exponent button on their calculator? All right. Then those, again, are the biggest things of today. There's one extra thing that I'm throwing your way today, and it's not my favorite thing, but I'm going to tell you why I am making you do it. Are you ready for my least favorite word in the world? It has destroyed education. Actually, it's a pair of words that is my least favorite word combo. Okay, I agree. That's a rough one. Anyway, standardized testing. Standardized testing has seriously destroyed education because we have to make sure you know how to do things that are considered math problems that really are not needed anymore. This would be among that. So you need to be ready to deal with problems like this. You're expected to not use a calculator, and you are using the knowledge that the log of 16 is 1.2, log of 5 is this number, log of 8 is this number. I want you to also keep in mind every single time you do one of these problems that you additionally have what is the answer to, hold on, let me rearrange my, yes. What is the log of 1 always equal to no matter what base you have? Zero. So keep in mind that these are extras that you can always use that kind of come along with the territory. Another thing is, because this is a base 10, if you want, you can use 10. What is log base 10 of 10? And I'm checking chat. It is 1. So realize that you can actually add these on. Now, what they're wanting you to do is use your log rules, which means you've got multiplication inside a logarithm or division inside a logarithm or a base to a power inside your logarithm. And you're going to expand. And you're going to expand until you see these show up, any of these. So for number 17, you have division inside a logarithm. When you expand that, you are doing what operation between the two logs? And I'll answer your question in just a second. What operation goes here with the log rule? Yes, subtraction. So what they're asking you to do is come over here and grab log of 5 is approximately 0.7. Log of 8 is approximately 0.9. That means that this is approximately negative 0.2. That's what they're asking you to do. So yes, you were right when you asked if it was approximately negative 0.2. Now, the reason I find it silly is because you can actually just pull out your graphing calculator and just find the log of 5/8. But this is something that you could be asked to do on a standardized test to show that you understand log rules and know that you would not have access to a calculator while you were doing these problems. Okay, number 18. Number 18. Does 25 sound familiar? What does 25 start moving around in your head? And these kinds of problems, the question that I see on the screen with these kinds of problems, they basically flat out give you these, and they expect you to know that you're supposed to use log rules to expand and then use those numbers. And so I want to make sure you understand what they're asking you to do if you run into them. Although I don't know where standardized testing is going, given that college applications are not requiring the SAT this year. Anyway, so with 25 being 5 squared, then we're going to rewrite this as log of 5 squared. You've got a couple of options. There are different ways to do this. I see 5 times 5. That is another way you can see this. So how about I do like either you see it this or you see this. If you see the exponent, then you can use the rule of bring the exponent to multiply in the front. What? So take a look at the fact that there are two ways you can look at it. It's just a matter of how do you see it. And then log 5 is 0.7. Oh, darn Wi-Fi.
I thought for log 25 you just add 5 together.
Well, what you want to see is that you have multiplication of 5 times 5 to give you the 25. But the logarithms end up being added when you split up that multiplication that is inside the logarithm. And this is where, this right here is why some people think logarithms are hard. Because right now you're just kind of trusting that the rules work. And you should end up getting 1.4. Either way, you're going to end up with 1.4. Okay?
Why isn't it 0.14?
Because I can't, wait, hold on. It might be because I can't multiply. Yes, tell your parents, my math teacher can't multiply. If you remember, I said earlier today that math is the thing that there are profound mistakes when you do math, more so than other subjects. Why did they give us log 60? So you didn't end up using log 16. Had I not taken out some of the problems, you might have used it. But also part of it is you have a bunch of information. Some of it you don't need, some of it you do need, and you've got to figure out what parts you need, if that helps. But the main reason is because I narrowed down the problems down to just 2 for each of those. Then that was for a base 10 logarithm. Now it's for a base 3 logarithm, but the same basic idea. And I want to add in that you can, if need be, you know that the log base 3 of 1 is equal to what number? Yes, 0. And if you need it, you know that log base 3 of 3 happens to be what number? Yep, 1. So realize that you can use these at any time. Do they really? Yes, they really have logarithm books. Yes. Well, okay, not quite like a brick. I would say like maybe this thick. I do. Well, actually, I have. Okay, yes, I do, but it's in my classroom. And it's like it was published, I think, in the 50s, 40s, or 50s. That's, yeah. I never had a mythical fax machine. Yeah. I actually never had to use a book of logarithms. By the time I came around, we already had scientific calculators that would find logs. I didn't understand why the textbooks still had log tables in the back. And I didn't know why they bothered with log tables. The calculator can find the logarithm. Why do we have these log tables? And then I came to find out that it was a recent thing when I was going through math that we didn't have to use tables. My parents had to use tables. Ha 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 ha, and slide rule. Ha 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 ha. Anyway, moving on. So you need to look at 16 and figure out through multiplication, division, exponent, how can we break that up with a 5 and a 2? Anyone think they see it? There we go. Mm-hmm. Almost, though. 16 is 2 multiplied a bunch of times. So first, we're going to write, you can either say it is 2 times 2 times 2 times 2 inside the logarithm, or you can say that it is 2 to the power of 4. And so if you're looking at it from the multiplication standpoint, that means that this will split up into addition. But isn't it interesting that this kind of comes full circle? And you can see that this gives you the same thing as this when you multiply the 4 in front. So you just need to take 0.6 and multiply it by 4. And that will give you 2.4 if I can do multiplication this time. And then, what about the next one? We've got 100. Can I break 100 up into 2s and 5s? Mm-hmm. So maybe what you start off with is realizing 100 is 10 times 10. And that means that what you actually have are 2 2s and 2 5s.
Could you put log 3 to the fifth times log 3 to the second squared? Like they're in parentheses in the square.
So you mean 2 squared and 5 squared? Like that? Let me make. Yes, you can. And when math rules are used correctly, there are different ways you can go about the problems, especially here. You can really start to see how many different ways you can arrive at the same answer. So you can either see it as 4 numbers multiplying and then add 4 logs together, or you can see that this is adding these 2 logarithms and then bringing the exponents and multiplying them in front. And so then you can use 2 times 0.6 is 1.2, and the other one is 3. And there you go. At this point, I've actually gone over the things that are new today, but I can go back and go over. Um,
6 squared, 1.5 squared.
oh, you want to make sure that the exponent you have has to turn into multiplication. Yeah, darn those log rules. And I've got to tell you, log rules really take some getting used to. And if you go into a pre-calculus class after this or intro to calculus, you'll see logarithms again. And you kind of need to before you're expected to just remember them. Calculus students are expected to remember all these log rules, even if they haven't used them for a couple of months. And that's actually the hard part of calculus, is remembering all the other things that you've learned over the years. It's not the new material. Okay. The only thing I haven't gone over with you are, Also, I have something in a wrong section, but I'm not bothering moving it right now. This actually belongs with the directions that are up here. I don't know. I don't know why I did that. But let's go over some of these real quick, and then I can see if you have any questions with homework and things. And I've got to be careful with the time. Okay. So with 10, 11, and 12, because this is understood to be base 10, you should be expected to at least realize that that means x is 10 to the negative 3. And the best you are going to do without a calculator is just to write it as 1 over 1,000 or in decimal form, whichever. But in this triplet of problems, I'm wanting to express to you what you can do without a calculator if you're not allowed a calculator on a test. It's more an issue of testing, though. It's not an issue of you're out and about in the world and your life depends on remembering log rules.
You're held at gunpoint.
That's always the big joke about math. It's like, yeah, like this is going to save my life someday. But you should see this, and if you are not allowed a calculator on some standardized test, be able to see, hey, that means x is 10. And number 12, do you see the answer to number 12 without me needing to say a whole lot? If you get an answer of 0 from a logarithm, no matter what the base, what was the input? 1. Mm-hmm. And if you need to go through the process, if I 10 to the power both sides, I get x equals 10 to the 0, which is 1. Then this set of problems up here, I want to make sure you're clear on, and you may enjoy these problems on the test.
Wait, can you go back down to the ones below for a second?
Yes, yes. With 6 through 9, you may hope to see these on the test. Take a good look at them. Take a really good look at them. With 6 and 7, you should see that log without a base written is understood to be log base 10. If what's in your logarithm is that same base number to a power, you can quickly solve it or evaluate. Okay, Dylan. Oh, if you have to leave in 5 minutes for an appointment, I can leave the quiz open for you, and you can do it later tonight, just not too late, as soon as you get home. Does that sound good? Okay. Yeah, because you're not going to want to try and get that done right now while you're supposed to be leaving. But I'll keep it open and keep an eye out. Okay. Do you guys see for number 6 that the exponent -7 is what that simplifies to? Because the understood base 10 matches. Do you see that with number 7, the answer to that is 1? Because we understand the exponent on 10 is a 1, and we understand that the base of that logarithm is a 10. And these expressions are just to make sure that you understand the inverse nature of the two functions. So when you look at number 8, do you see the base of the logarithm and the base of the exponential match?
Yes, so would that make the answer 5?
Yep. Who wants to see these problems on the test next week? Yeah. And then number 9. Number 9 is the reverse direction, where it has the exponential and then the log inside of it. But as long as the base of the exponential and the base of the logarithm are the same, they will cancel each other out. And all that I have left now are problems that are very similar to what I went over with you yesterday in classwork. I just know that they are a bit tougher to work with. And looking at the time, I'm going to just run through these right now and know that we have no new classwork the rest of the week. So the rest of the week I can go over questions you have on homework that you didn't understand. If the base is no, I'm not going to do that to you. All right, so quickly I'm going to run through these. The quickest way to do number 3 is, because you have a 0 on the right side, make your life easy and add the logarithm log base 2 of 9x, add it to the other side. However, you could use the log rule that subtraction turns into division, but you will wind up with the same answer as long as every rule you use is correct. In this case, the logs cancel each other out, and you're left with the insides. And again, I'm kind of writing this a little bit quickly. But let me mention that had you seen the division property and made this log base 2 of x plus 2 divided by 9x equal to 0, what I want you to see from that is you undo this logarithm by 2 to the powering both sides. That undoes the logarithm, and what is 2 to the 0 power? It's 1. And then you have this fraction that equals 1, and you multiply 9x to the other side, and all of a sudden you find yourself like you found a wormhole and you're over there now. Logarithms probably feel like wormholes. You just got sucked into some other strange dimensional place. All right, then number 4. You want to multiply log 29 to the other side. And then those are both base 10 logarithms. They undo each other. You have 5x minus 1 is equal to 29. And we wind up getting x equals 6. You are supposed to check your answers, though, that they make positive numbers go in logarithms. So far, we're good. Number 5, you must condense that logarithm. This time, the other side is a 2. It's not a 0. You don't have any choice. But you've got to be careful because you've also got this 1/2. What I'm going to do is I'm going to start by saying that 1/2 is an exponent. And 49 to the 1/2 power is really just the square root of 49, and the square root of 49 is? Yes. From here, you can combine due to subtraction. And then you're almost there. But keep in mind, don't undo a logarithm until it is condensed. So you 8 to the power both sides. 8 squared is 64. And a little bit of arithmetic later will get you an answer. And I'm sorry, but right now I need to just kind of jump over there. Wherever, here it was. Now, you do need to check, and it does work out. It's not exactly a pretty number. Wait, yeah. You can write it in decimal form if you don't like writing it as a fraction like that. But I need to get that quiz open for you. Before I open the quiz, let me remind you that in section 3.4, you got the third of the 3 big log rules. And you're going to be expected to expand and condense logarithms using all 3 rules. I am not giving you the hardest problems on this quiz. I'm giving you the milder problems. The other thing that you want to remember that we learned in this section was, wait, why is it not in there? Okay, sorry. Let me go over here. Oh, wait a minute. Okay, I just realized something. Oh my, okay, I'm going to stop recording because I'm about to make